Hello everyone. Today in this video we will do the quick revision of the chapter electricity. Electricity is a form of energy which we all use in our daily life. Electric current. Electric current is the amount of charge flowing in unit time. ಒಂದು ಯೂನಿಟ್ ಟೈಮ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗೋ ಚಾರ್ಜಸ್ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. Mathematically we represent electric current as I is equals to Q by T. Here I is electric current, Q is charge and T is time. SI unit of current is ampere, SI unit of charge is coulomb and that of time is seconds. Electric circuit. It is the closed path of current. Current flow ಆಗೋ closed path ಅನ್ನು ನಾವು electric circuit ಅಂತ ಕರಿತೀವಿ. The direction of current is always opposite to the direction of flow of electrons. Now let's see what is electric potential difference. If the electron or the charges has to move, there must be potential difference. Potential difference is the work done in moving a unit charge from one point to another point. One point ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗೋ ಚಾರ್ಜಸ್ ಗೆ ಬೇಕಾಗೋ ವರ್ಕ್ ಡನ್ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Mathematically we represent potential difference as V is equals to W by Q. Here V is potential difference, W is work done, charge that Q is charge. The SI unit of potential difference is volt, SI unit of work done is joule and the SI unit of charge is coulomb. Now let's see what is Ohm's law. Ohm's law states the current flowing through a conductor is directly proportional to the potential difference across its ends provided the temperature remain constant. So we can write it as V is proportional to I. V is equals to Ri. Here R is the proportionality constant called as resistance. Resistance is the property of a conductor which opposes the flow of charges. R is equals to V by I. Here SI unit of resistance is Ohm. Now let's see on what factor this resistance depends. Factors affecting resistance. Resistance is directly proportional to length. Here length ಜಾಸ್ತಿ ಆದಷ್ಟು resistance ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Resistance is inversely proportional to area of cross section of conductor. Area of cross section ಜಾಸ್ತಿ ಆದಷ್ಟು resistance ಕಡಿಮೆ ಆಗುತ್ತೆ. R is equals to rho L by A. Here rho is the proportionality constant called as resistivity. So the SI unit of resistivity is ohm meter. Now let us study about the series and parallel combination of resistors. Resistors in series. R1, R2, R3 are the resistor. They are connected end to end. This is voltmeter connected in parallel. This is an instrument which is used to measure the potential difference. Ammeter is a device which is used to measure the current flowing through the conductor. This is battery and this is switch. The current flowing through each resistor is same, but the potential difference for each resistor is different. Therefore, total potential difference is equal to the sum of the potential difference of each resistors. V is equals to V1 plus V2 plus V3 and so on. By using Ohm's law, we can write V as IR, V1 IR1, V2 as IR2 and V3 as IR3 and so on. By taking I common, we can cancel both the side. It becomes R is equals to R1 plus R2 plus R3 and so on. Now let's see about parallel combination. Here resistors in parallel. R1, R2, R3 are connected in parallel. The one end of each resistor is connected to one point and the other end of each resistor is connected to another point. The current flowing through each resistor is different, but the potential difference is same. We can write I as I1 plus I2 plus I3 and so on. By using Ohm's law, we can write I as V by R. I1 is equals to V by R1. I2 is equals to V by R2. I3 is equals to V by R3 and so on. Now take V common and cancel both the side. You will get 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Now let us study about heating effect. When a current is passed through a conductor, some amount of electrical energy gets converted into heat energy. This effect of electric current is called as heating effect of electric current. Here we will also study about Joule's law of heating. It states that the heat produced in a conductor is directly proportional to the square of the current, and it is directly proportional to the resistance of a given current, and it is directly proportional to the time for which the current is passed. Mathematically, we write it as H is equals to I square RT. Here H is heat energy, I is electric current, R is resistance, and T is time. Electric power is the rate of doing work. It is also a product of potential difference and current. Here P is power and the SI unit of power is watt. By using Ohm's law, if you write V as IR, it becomes I square R. And if you write I as V by R, it becomes V square by R. Commercial unit. Commercial unit of electric current is kilowatt hour. 1 kilowatt hour is equals to 3.6 into 10 raised to the power of 6 joules.